Okay, so now due to the nature of some of these equations that involve logarithms and derivatives, it might actually be useful to use what's called logarithmic differentiation because it's going to really allow you to make use of the properties of logarithms. Now, it's really going to depend on like what you are comfortable with. Sometimes it may be easier for one student, but another student may find the same problem harder. So it's going to be up to you. But let me just show you an example of what I mean. So let's say we want to differentiate this equation. Maybe you're probably like, oh man, this is complicated. I don't want to mess up using the chain rule and quotient rule and all that. So what we can do is take the log of each side, and we would get the natural log of y to be equal to the natural log of the entire right side of x minus 2 squared over the square root of x squared plus 1. And then from here, we can break it up by using the logarithmic properties. So we're going to separate the right side by using, the difference of, remember the natural log of a over b is equal to the natural log of a minus the natural log of b using the difference property. So let's rewrite the right side. So then we have the natural log of y is equal to the natural log of that of x minus 2 squared minus the natural log of x squared plus 1. I'm going to rewrite that as the 1/2 power. Also, then we can use the power rule to make these coefficients of those logarithms. So then this further becomes the natural log of y being equal to 2 times the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. So remember the natural log of x to the, or let's just say it's usually seen as like natural log of a to the x. You can make this equal to x times the natural log of a, usually called the power property. Okay, so then from here, we just differentiate. And the one thing we have to remember is that we have to use implicit differentiation. So going through this, we would take the derivative of this with respect to x. So we would have the derivative of the inside, 1 over y, multiplied by dy dx. Just remember that key component. If you remember that, the rest becomes pretty simple, as long as you're comfortable with your algebra, that is to say. So then we're going to have 2 times the derivative of the natural log of x minus 2, which will just be 1 over the inside. So 1 over x minus 2 minus 1/2 times 1 over x squared plus 1 times the derivative of x squared plus 1 using the chain rule. So times 2x. Now, from here, we're going to solve or isolate the dy dx and multiply the right side by y. And we'll get dy dx as being equal to y times this whole thing, which will be 2 over x minus 2 minus these 2's will cancel. So minus x over x squared plus 1. And then let's replace the y with the original expression here, x minus 2 squared over the square root of x squared plus 1. So then this becomes dy dx being equal to x minus 2 squared over the square root of x squared plus 1 times all of this. All right, now it's pretty much a lot of algebra and making sure that you are confident in your pre-cal or algebra 2 skills. So what we can do is combine all of these terms by using common denominators, and then basically just simplifying this as far as we can. But pretty much it's just algebra now. So we can multiply this by x squared plus 1 over x squared plus 1, and then this one by x minus 2 over x minus 2. And let's rewrite that x squared plus 1 as under that square root as x squared plus 1 to the 1/2 power. So all of that will be then 2 times x squared plus 1 minus x times x minus 2 all over x minus 2 times x squared plus 1. And now we just multiply across, as I'm going to try to do this is without making any mistakes as best we can. So let's see what we got. So dy dx will be equal to x minus 2 squared. This x squared plus 1 times that x squared plus 1. So we have x squared plus 1 to the 3/2 multiplied by up here by, let me just leave the brackets, by 2x squared plus 2 minus x squared plus 2x over x minus 2. And actually, let me take away these brackets because I already have that factored out. I don't want to confuse this with that. And from here, we can take out 1, we can factor out an x minus 2 from here and here. And we can simplify that. And we should be able to get this down to 1 more. Dy over dx. We just have an x minus 2 there, because one of those goes away. Here we got just an x squared plus 2x plus 2 over an x squared plus 1 to the 3/2. All right, and there you go. Now, I didn't say this was going to be simple and quick. These ones always tend to be like this. So pick your poison if you want to use this method or the chain rule. But either way, you're going to have some fun going through, some process like this. So good luck.